All right. Chapter 4 is just going to be more derivatives here. Uh, and the first section and what these videos are going to talk about is one more rule, which is the chain rule. And this is a big rule. This is really important, and it's used constantly. This is the reason why it gets its own section compared to any other rule gets shared, but this rule gets its own section. It's that important. And the idea of it is we've talked about function operations for these rules. We talked about how if we're adding or subtracting functions, we can take the derivatives of each piece and add and subtract those. If we're multiplying two functions, we do the product rule. If we divide two functions, we do the quotient rule. But the one function operation we haven't discussed is composition, which is the idea of I stick a function in another function. So for example here, 5x plus 3 is a function, excuse me, and I'm squaring it, and the squaring is another function. So it'd be like if I said that x squared was a big function, and 5x plus 3 is being stuck in that. In other words, it's being composed. And up until this section, really our only recourse if we wanted to get the derivative of this would be to FOIL out this binomial, which would be 25x squared plus 30x plus 9, and then take the derivative of that, which would be 50x plus 30. Excuse me. And that works, but then what happens if we deal with something like this? 5x plus 3 raised to the 22nd power. Now, could we multiply that out? Yeah, we could use Pascal's triangle, multiply it all out, then take the derivative of that gigantic 23-term polynomial. But the alternative to that is what's the chain rule. And so the chain rule says that I have composition. I have some function inside of some other function. And just because you're going to hear me saying these terms a lot, g of x would be inside, and my f of x, or my f, is outside. So I have an inside function, I guess I should say function, and an outside function. And the idea of this is if I want to take the derivative of composition, this is the derivative of the outside. And then I'm going to multiply that by the derivative of the inside. So derivative of the outside times derivative of the inside. Now one thing to note is when I take the derivative of the outside, the inside of that isn't changing. That only changes when I do derivative of the inside at the end here. So for example here, 5x plus 3 would be the inside, and the 22nd power is the outside. So if I want the derivative of h, that's derivative of the outside, which would mean do the power rule. And when I do that, I'm not doing anything to the 5x plus 3 yet. I just took the derivative of something to the 22nd power, which is the power rule, times the derivative of the inside. And now I look at what's the derivative of 5x plus 3, which is 5. And this even works on the example we started with. I would consider the 5x plus 3 to be the inside and the second power to be outside. So I could say that f prime of x is derivative of the outside, which is the second power, so I do the power rule, not changing the 5x plus 3 yet because that's on the inside, to the first power, times derivative of the inside, and derivative of 5x plus 3 is 5. And if I simplify this, this actually does give me the 50x plus 30. The next video is going to go through some more examples so you can start to kind of see this. And then in class, I know I've been doing Newton's notation here. I will also go through Leibniz notation in class.